Kessler Syndrome. Entropy. Wearing a Newtonian mask. At first glance, Kessler Syndrome looks like a purely mechanical problem. Satellites collide, debris spreads, risk increases. Classic Newtonian stuff. Masses, velocities, conservation laws doing their deterministic dance in low Earth orbit. But that's just the costume. Underneath, this is entropy in full command. The essence of Kessler Syndrome is not motion, but irreversibility. Two satellites collide at orbital velocities and fragment into thousands of shards. Each fragment carries its own trajectory, energy, and timing. The system's phase space explodes. What was once a low-entropy, highly ordered configuration, a handful of carefully placed machines, becomes a high-entropy cloud of independent projectiles. Nothing supernatural happens, yet something permanent does: the loss of recoverable order. This is where Newton hands the baton to Ludwig Boltzmann. The laws of motion are time-reversible. The statistics of large systems are not. In principle, every collision could be undone. In practice, the probability of all fragments spontaneously recombining into functioning satellites is so vanishingly small that possible becomes indistinguishable from never. Entropy doesn't forbid reversal, it makes it cosmically unlikely. The paradoxical sting of Kessler Syndrome is that the process becomes self-sustaining. Once debris density crosses a threshold, collisions generate more debris faster than orbital decay can remove it. Even if humanity launches nothing new, the system continues its march toward disorder. This is entropy's signature move. After a critical point, the future no longer needs active participation. The arrow of time locks in. Calling it a space junk problem misses the deeper lesson. Kessler Syndrome is an emergent thermodynamic trap. No malicious intent, no single catastrophic decision, just many reasonable actions accumulating until the system's options collapse. Order is fragile. Disorder is robust. Space, with its near-perfect energy conservation and minimal dissipation, simply makes this imbalance brutally obvious. Seen this way, Kessler Syndrome is not an anomaly of the space age, but a warning written in orbital mechanics. When energetic artifacts accumulate faster than a system can dissipate them, entropy takes over wearing the mask of ordinary physics. Newton supplies the equations. Entropy decides the ending.